Okay, section 5.6, standard form of a linear equation. So we've been working with writing equations, and there are a couple different forms, actually several different forms that we should be familiar with at this point. At the top here we see slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Last time we talked about point-slope form, y minus y sub 1 equals the slope m times the quantity x minus x sub 1. In point-slope form, you are able to see a point with the x sub 1 and y sub 1 values. So you have one ordered pair, and then you also can infer the slope, whatever the number is in the spot where the m now resides. From the past, we've also talked about the equation for a vertical line versus the equation for a horizontal line. So just remember, for a vertical line, it is x equals a number. And for a horizontal line, it's y equals a number. And since this whole unit is about writing equations, you could expect to have to write equations for vertical lines, write equations for horizontal lines, give equations in slope-intercept form, and give equations in point-slope form. Today we're going to add a fifth one to the list. So today we are working with equations in standard form. Okay, so standard form, and sometimes it's referred to as general form, looks like this: ax plus by equals c. And first thing I want you to notice is that the a, b, and c are capital, and the a and b there kind of function as coefficients. So the coefficient of x is a and the coefficient of y is b. C stands all alone. It's just a constant number. It does not have a variable associated with it. So some things you want to notice, notice how the x and y are both on the same side. And typically we're going to see them on the left-hand side. They could be on either side, but the important thing is that both variables x and y are on the same side, and the constant, or what I sometimes call the loner, is on the other side by itself. That's what we'll call standard form. So that's pretty much what the first paragraph says. The second paragraph talks about fractions. So when we write equations in standard form, typically we want the a value and the b value up here, the two coefficients. We want those to not be fractional numbers. We would prefer to have them as integer coefficients. So just remember, if we use the term integer coefficients, we're talking about coefficients that are whole numbers or their opposites, not fractions, not decimals. And to give you kind of an example of something in standard form, something that would look like standard form, for example, if we had something like 3x plus 5y equals 60. That would fit standard form. Notice how x and y are both on the same side, and the constant 60 is by itself on the other side. You've seen this before when we graphed equations with using intercepts. This is the form we would use to plug in 0 for x if we wanted to find a y-intercept, or plug in 0 for y if we wanted to find an x-intercept. So you've definitely worked with standard form before, and you've probably heard me mention it in class by now. All right, so let's take a look at what it's going to take to write an equation in standard form. This is your first example, so go ahead and copy this one down. And these are going to be the basic steps you're going to go through. So here we have negative 5x plus 11 equals 1/2 y. And first we want to look at it and say, well, is that already in standard form? And the answer is no. And hopefully you can maybe come up with a couple reasons why it's not in standard form. One of those would be is that the variables are not on the same side. So we want to get x and y on the same side. Another reason we might not consider this in full-fledged standard form is we have that 1/2 in front of the y. And remember, we don't want to have fractional coefficients here. We want to have all whole numbers and their opposites. We want to have all integers. So we're going to have to change that 1/2 around. So first thing we're going to do is clear fractions. So if we have any fractional coefficients, we're going to change those fractions. I'll show you how to do that in a second. After that, we'll get the variables on the same side, and we'll get the constant by itself. And you basically just do whatever it takes to do that using the algebraic properties that you're already familiar with. So just some basic algebra. And then I'm going to show you at the end here that sometimes, actually every time, there are going to be two possible answers. So some of us might go one way and others of us might go a different way. All right, so let's take a look at clearing the fractions. I have that 1/2, okay? And really I want to get that 1/2 to turn into a whole number. So basically just ask yourself this question. What would I have to multiply 1/2 by to make it a whole number? And the trick is to look down here at the denominator. Okay? If you see here that the denominator is 2, a good way to clear fractions is just to multiply everything by 2. So remember, whatever you do to one side, you must do to the other. But we will begin by taking the whole right side here and multiplying it by 2. And algebraically, if I multiply the right side by 2, that means to keep things balanced, I'm going to have to multiply the left side by 2. You probably want to write another line and show both of those steps. Okay, let's see what happens. After I've multiplied both sides by 2, on the left, I'm going to have something like negative 10x plus 22. Remember, that's distributive property. And then 1/2 times 2 is the same as 1/2 times 2 over 1. That's 2 over 2, it's 1. So 1y. And no one really writes 1y, we'll just write y like that. Okay, so we've cleared fractions. Next, we're going to have to get the variables on the same side. And we're going to have to get the constant by itself on the other side. And you can see this is going to take more than one step here. So some of you might begin by subtracting the 22. Others of you might begin by subtracting the y. Both are valid. I'd probably take away y from both sides. When you do that, you're going to get everything on the left. Negative 10x minus y plus 22 equals 0. It's kind of weird. You have nothing on the right-hand side for a second. But remember, we're going to get the constant over there by itself. So I've got x and y on the left. All I want to do now is get that constant on the other side. So I can take away 22 from both sides to accomplish this. Notice when I do that, that will cancel out, and I'll end up with negative 10x minus y equals negative 22. That would be the equation in standard form. Okay. Now, there is another possibility. You'll notice that I began by subtracting y from both sides. Okay. There's nothing to say that I could not have added 10x to both sides. Actually, it would have been a lot easier. It would have just taken one step had I added 10x to both sides, because I would have the variables on the same side and the constant by itself over here. And notice if I did that, I end up with actually the opposite of what we got for our answer right there. Instead of a negative 22, I'd have a positive 22. And instead of negative y and negative 10x, I'd have positive y and positive 10x. So the point is, we might take different initial first steps. Some of you could end up with positive 10x plus y equals positive 22. And that would also be a valid equation. Okay, so both of these work, and I want you to notice that one is the complete opposite of the other. It's as if we took this equation and multiplied it by negative 1. If you multiply everything by negative 1, you end up with this guy. Okay, so with standard form, you'll have two possible answers, and just know that I will accept either one. And we'll talk a little bit later why you can have two possibilities there. Okay, so let's try one on your own. Here's example 2. Write the equation in standard form with integer coefficients, and I've given you negative 16 plus 4y equals 5x. Go ahead and put that in standard form on your own first, and then unpause to check answers and make sure that we're doing it correctly. All right, go ahead and hit pause now. Okay, this one was kind of easy because you did not need to clear any fractions. So really just testing your ability here to get the variables on the same side. I think the easiest way is probably to take away 4y. So if we do this, it's just going to have us working with one step here. So if I take away 4y, I'm going to end up with negative 16 on the left-hand side. And then I'll have 5x minus 4y. on the right-hand side. Now technically it doesn't really matter which side things are on. Personally, I think it's going to be a better habit if you have the x's and y's on the left-hand side. So I can just do a little mirror flip here, and it will still be the same equation. So let me go ahead and write 5x minus 4y on the left being equal to negative 16 on the right. Okay, now I realize there might be some of you who did not come up with this answer. Maybe you decided to subtract 5x and then add 16. That is completely valid as well. So you could also have this as a possibility. Some of you may have negative 5x plus 4y equals positive 16. And that would work as well. Okay, so both of these are valid. And as long as you have one of them, you are good to go. Let's do another example. This time we're going to practice having some fractional coefficients. Remember, you're going to have to get rid of that fraction that you see there on the right. It says write the equation in standard form using integer coefficients. Go ahead and try this one on your own now, and then do not unpause until you have your own answer sitting in front of you. All right, good luck. Okay, this one actually looks pretty similar to the first example that we did earlier. And I want to begin by clearing fractions. So if I have 1/3 here, the easiest way to clear these fractions is to multiply by whatever the denominator is. So my denominator is a 3. I'm going to multiply by 3. Some of you might think, oh, I'm going to multiply by the reciprocal, and that works too. But there are times where you won't have a 1 in the top, like you might have 2/3 or even like 5/3 or 7/3. Don't feel the need to multiply by the reciprocal because it might end up making some of your other numbers fractional. If you multiply by just the denominator, it's always going to work out nicely. So we'll multiply the right side by 3. And remember, with multiplication and division, it affects the entire side, so we want to multiply the left side, the whole entire left side, by 3. And that's going to give us some distributive property there. So let's go ahead and distribute this 3 to both guys inside here. 3 times negative 3x is going to be negative 9x. Positive 3 times positive 8 is going to be positive 24. And 1/3 y times 3 would be 3 over 3y, which is 1y, which is just y. Okay, so that's the first step. Now we need to get x and y on the same side. And kind of like the last problem, I think the easiest way to do this is to add 9x. And when I do that, I'm going to get 24 all by itself on the left. And I'll have positive 9x. And since it's a positive y, we write plus y. Okay, and then I will mirror flip those so I can have my x's and y's on the left. 9x plus y equals 24. Sometimes a common question is, well, is it okay if I wrote the y first and then the x? You know, I want you to really fit the form, and the form does say ax plus by, so let's keep the x first followed by the y. When we get to the second semester stuff, especially linear systems, systems of equations, it just might be better if we have the x first and then the y. That way we kind of have a common language there. So I am going to ask that you put the x stuff first and then the y stuff to follow on the left, and then have the constant by itself on the right. Now, some of you might not have that answer. Hopefully by now you can guess what the other answer should look like. You might have made some different first steps. You could have subtracted y from both sides and then subtracted 24, and you would have ended up with negative 9x minus y equals negative 24. So this answer is correct as well. Okay, you can have either of those. All right, let's try one more like this. Write the equation in standard form with integer coefficients. This one's slightly different than the examples before it. So just kind of apply your knowledge. Go ahead and try this on your own. Good luck, and then resume the video when you're ready to go over your answers. Okay, so you have 6y equals 9 plus 3/4 x, and I want to begin by clearing fractions. Okay, so to clear fractions, and that is the term I'll use throughout the year, clearing fractions, I'm going to multiply everything by the denominator here. It's just a little trick up your sleeve that always works. Notice that you have to multiply the entire side by 4. Hopefully you remember to multiply the entire side. Just like over here, we're going to multiply the entire side by 4. And those parentheses on the left side, they're not necessary. I use the parentheses to show you guys, hey, it's the entire side no matter what. Okay, watch how everything will become whole numbers. 4 times 6y, we get 24y. 9 times 4, that's distributive. Okay, 9 times 4 is 36. And then 3/4 times 4. Okay, so think of that as 3/4 times 4 over 1. 3 times 4 would be 12, 4 times 1 would be 4, so if you need to do a little side work on that, no shame in that game. Pretty easy stuff. 12 over 4, which we know is 3. And that's how we clear the fractions. So this becomes a 3x. Okay, is it in standard form? No, but it's really close. To get there, I am going to do what? I'm going to take away 3x from both sides. And notice I end up with negative 3x plus 24y on the left equaling 36 on the right. And that would be my standard form. Now I want to check that and make sure that some of you guys might have the other possibility. So if you have the other possibility, maybe you want a different way, you would end up with positive 3x minus 24y equals negative 36. And that answer will work as well. Okay. Don't think that you can combine 3x and 24y. Remember, those are different variables, x and y, so they are not like terms. And that's why they never combine in this step right here. So don't think that you can say something like 24y minus 3x is 21x or 21y. It doesn't really work that way. They're not like terms. It's like Oreos and Chips Ahoy, two different kind of cookies. All right, see if you can apply this now. Okay, example 5, I think we have 2 more. Using standard form, write the equation for the line that has a slope of 2 and passes through the point 3, 7. Now, this is a completely different type of problem. It's okay if you feel a little frustrated with it. I do want you to attempt it on your own. But this one's going to involve a little bit of work. You're not going to be able to go directly into standard form. Okay? You haven't been given an equation. You're going to have to generate something to work with. So think about some of the forms we've used before, and maybe that would be a good starting point. Equation for a line that has a slope of 2 and passes through the point 3, 7. Where might be a good place to start, and then kind of try to work towards standard form. Okay. Go ahead and work on this on your own. Pause the video, see how far you can get, maybe even all the way to an answer, and then unpause when you're ready to go over answers. So the deal with standard form is when you look at standard form, you can't really see a slope or a point or anything like that. I cannot take this information and put it directly into ax plus by equals c. But what I can do is put it into a form that I'm already comfortable with. And since they have given me a slope, and since they have given me a point, what do you think a good form would be to use? Well, point slope form. So let's recall that point slope form is y minus y sub 1 equals the slope times the quantity x minus x sub 1. And I have all of the information that fits that form. I have an x sub 1 right here, I've got a y sub 1 right here, and I have a slope of 2 right over here. So let me just plug those guys in. I'm not giving it in standard form, but I'm going to start with a point slope form. So y minus y sub 1, my y sub 1 is 7, so I can write y minus 7. My slope is 2, so I'm going to put in a 2 for the m. And then x minus x sub 1, my x sub 1 here happens to be a 3. Notice I didn't have any of those negative coordinate values, so I didn't have to worry about changing a minus, a negative to a plus. But that's point slope form. Okay, right here we're looking at point slope form. Well, could I take this and maybe move it into standard form? You should be able to move fluidly back and forth between point slope form, standard form, slope intercept form. It's just using the algebra you already know to manipulate things to get them to look the way you want them to look. Okay, so if you had to make a move from here, what do you think you might do next? What is your gut telling you? Well, I could distribute this 2, right? Okay, so let's see what happens when I distribute that 2. I'm keeping things equivalent, just writing it a different way. You get y minus 7 equals 2 times x is 2x, and 2 times negative 3 is negative 6. Okay, notice how we have a y on the left, an x on the right. I've got a negative 7 on the left, a negative 6 on the right. Okay, what can I do here to maybe put this in standard form? How could I work a little bit more closely to that? Well, let's try getting the constant stuff on the right. So what would I do to get the constant stuff on the right? I would add 7. That's one possible step. You might have taken a different step, and that's okay, but this is how I'm going to do it. When I add 7 to both sides, I get y equals 2x, and then it's a war problem. Positives win, they win by 1. Notice, what type of form are we in now? We started in point slope, and all of a sudden I've arrived at slope intercept. That's y equals mx plus b. You can visualize what this would look like. It crosses the y-axis at positive 1. It's got a slope of 2 going up the roller coaster, kind of steep. Okay. Now let's go from slope intercept form. Let's take it all the way to standard form. Shouldn't be too hard. What would you do here to put this in standard form? Well, you can take away 2x from both sides. And when you do that, you're going to get negative 2x plus y equals 1. And that would be your standard form. If you happen to take a different route, you may have ended up with positive 2x minus y equals negative 1. And that would suffice as well. So either of those is correct. Notice I used my information to start with a form that worked for me. I started with point slope form. And then I just used my different algebraic properties to balance things out and eventually get the x on the left and the y on the left and all the constant stuff over on the right. I went through distributive property, and then I added 7 to both sides, and then I subtracted 2x. Nothing you guys don't know how to do. All right, so let's try this one on your own now. Very similar. Using standard form, write the equation for the line that has a slope of negative 3 and passes through the point 1 comma negative 5. See if you can get this one on your own. Good luck. Okay, I'm going to try this one the same way. I've been given a point, I've been given the slope, so I'm going to put this in point slope form. It's going to be y minus y1, and y sub 1 is negative 5. So y minus negative 5 equals, my slope is negative 3, so I'm going to put that in for m. And then it's x minus x sub 1. My x sub 1 happens to be 1. Okay, so that's sort of my starting point right here. Well, what am I going to do first here? I think before I do any kind of distributive property, this probably needs to be simplified over here. So instead of writing y minus negative 5, let's go ahead and change that to y plus 5 equals negative 3 times x minus 1. And that's a more simplified format. And now I think we can go ahead and start to simplify things. So I'm going to distribute this negative 3. When I do that, I get y plus 5 equals negative 3x. Negative 3 times negative 1 is positive 3, so plus 3. And now I can start manipulating this a little bit more easily. Kind of like last time, I'm going to work with my constants first here. I'm going to take away 5 from both sides. And when I do that, I get y equals negative 3x minus 2. I can see my slope-intercept form right there. And I'm very close to standard form. All I need to do at this point is add 3x to both sides. So final answer, 3x plus y equals -2. If for some reason you went a different route, you might have -3x minus y equals +2. And that could work as well. All right, so to sum up, different ways to write linear equations. We have slope-intercept form, point-slope form. Remember, vertical line is x equals a number, horizontal line is y equals a number, and then today you can add in standard form, ax plus by equals c, where a and b are both the coefficients of x and y, respectively. All right, thanks for your attention. Hopefully you did well with this, and I will see you in class next time.